And so today we're adding a new layer for solving equations. The work that we did over the last couple of days was always solving our quadratics. Remember, anything with x squared in it? Solving quadratics by factoring. Now, technically speaking, we could still factor this in order to solve it. And so, but I'm going to take a different route because we actually don't need to factor it here. There's another way we can go about doing these. And the reason is because this one just has the x appearing in the equation once. So if I had x squared plus an x in here, then I'd really have to use factoring. But since I don't have another x in there, I only have the one x, I can actually just solve this algebraically, like just moving stuff from one side of the equation to the other kind of thing. All right? So given that there's only one x there, the very first thing I'm going to do is I'm going to get the part that is squared by itself first, which means I got to move out the 1. So I'm going to add 1 to both sides. So we now have x squared equals 9. All right. I now want to get the x by itself. So that means I have to get rid of the squared. What do I do to both sides to get rid of a squared? Square root, absolutely. And so if I take the square root of both sides, we end up finding that x equals 3. But then there's going to be an extra little wrinkle with this answer. So we're going to be taking a look at this problem a different way and then looping back to take a look at this work. So we've also been solving by graphing, right? Now you don't actually need to make this graph. You can if you want to, but we're going to go through it pretty quick. If I were going to solve this by graphing, I of course would have to graph y equals the left side. So we graph y equals x squared minus 1, and we would also graph y equals the 8. Well, if I'm going to graph this y equals x squared minus 1, I don't even need to find the vertex here using like x equals negative b over 2a. Because with the way it's written, I can actually just look at it and figure out what's the minus 1 doing to the graph. Because again, there's no x term in the middle that's messing it all up. So what does that minus 1 do to the graph?
Just the y value?
Yep, that minus 1, that's our y. That's where our y starts. It's telling us that this thing starts down 1. And so I'm going to be putting my first point down 1. That's all that means. And so knowing that, I now can graph my x squared graph like I normally would from there. And then the y equals 8. Notice there's no x in that, so that's just a horizontal line. Now notice when we do that, we get two solutions. So we can see here that we're finding out that x would equal negative 3 and x would equal positive 3. But when we just did the work earlier, algebraically, we only got the answer of the 3, but we did not get the negative 3, which tells us that there's an extra layer that we got to throw in on our algebraic work. So, in order to get that, we're going to have to get a new rule here. And you might want to write this down in your notes, might not, depending on how well you remember these things. The rule is that when we take the square root of both sides of an equation, and so you'll notice that this happens when we take the square root. So if we introduce a square root, we have to do this. Then we must account for both the positive and negative square root of our number. And so taking a look at our problem here, that means that I should, in my algebra, end up with both the 3 and the negative 3. So how do we show that? To show that, we insert this plus or minus in front of it. So it's not just equals the square root of 9, it's equals the plus or minus square root of 9. That little plus or minus symbol means both the positive and the negative versions of the number. Really, when I write something like plus or minus 3, that's the same thing as saying it equals 3 and it equals negative 3. Just, of course, mathematicians have that reputation for being lazy, so if we could shorten it into one short little statement, we do. But that's what that plus or minus symbol is telling us. And so every single time that we include or insert, create in solving the problem, the square root symbols, that's when I have to include the plus or minus. And so we wrote it as plus or minus 3. That then means that x equals both 3 and negative 3. So then having seen that one, we now can start tackling ones that have a little bit more involved in them. So write down this one, and then start solving it through, and I'll jump in and kind of join with you on the solving process after you've had a chance to hopefully get a few steps ahead. All right, so strategy-wise, what we're having to do first is we're having to get the squared part by itself first. And so in this case, you can see that the x is the only thing being squared. And so that's what I want to have by itself. So notice that means I got to move out the 5, and I need to move out the 7. I always want to move the addition and subtraction first, and then go and deal with the multiplication. So I'm going to start by subtracting 7 from both sides. Then we divide both sides by 5. Now that we're to this step, of course, that looks the same as the last one, right? So now, if x squared equals 9, then to get rid of the squared, I'm going to take the square root of both sides. And when I take the square root of both sides, that's why I write the plus or minus. So notice, it comes with the square roots when we insert them. And so x equals plus or minus 3, and therefore x equals 3 and negative 3 again. All right, next up, we're going to take a look at solving this equation, which is interesting because even though it's a very different equation type, this one's absolute value instead of a quadratic, it has a lot of similarities to our quadratic, as you'll see. So like with our quadratics, the very first thing we did is we had to get the squared part by itself. In this case, it's the same idea, except we have to get the absolute value part by itself, which means, of course, getting rid of that plus 3. So we subtract 3 from both sides first. So we have the absolute value of x equals 7. Now let's logic out. What could our solutions be? The absolute value of what equals 7? 7. I heard 7. Yeah, because the absolute value of 7 is 7. But the absolute value of what else also equals 7? Negative 7. And so, again, you'll notice that we should be able to get two possible solutions out of this. Because there's two different numbers that if I take the absolute value of them, I get the same thing that I'm after. And so, in order to get rid of the absolute value, it's not like some special operation like square root. But in order to remove the absolute value, we do have to create both a plus and a minus version of that answer. And so here we find that x equals negative 7 and 7. And again, that might be worth noting there to remind yourself that this is the step that we need to take on these. Next up, we're going to continue practicing solving these absolute values. So write down this one and then look at solving it out. All right, so again, we start by looking to see how we can get the absolute value part by itself first. So all I care about at the moment is getting the absolute value of x on its own there on the right-hand side. So that means I got to get rid of the 6 and the negative 4. Remember, I do want to get rid of the addition and subtraction first. So I start by adding the 4 to both sides, and then once I've done that, I can divide both sides by 6. Now we have 4 equals the absolute value of x. If 4 equals the absolute value of x, what would x equal then? Yep, both. Negative 4 and 4. We want to include both of those solutions. And notice where the plus or minus came in. The plus or minus appeared when I got rid of the absolute value bars. So it's when I'm undoing that part that creates the two solutions, that's when that plus or minus appears in our equation. All right, so now we're going to take a look at this absolute value equation, which has a slightly different flavor, as you'll see. So go ahead and write this one down, then we'll work it through together. And as we take a look at doing this one, we might be thinking we could get rid of the addition and subtraction first, but we can't here. Because this plus 5, it's trapped inside of the absolute value. Remember how we've been talking about how we have to get the absolute value by itself first? Notice that it already is by itself first. And so let's take a look before I actually show you what the math would look like. Let's think about this. I have the absolute value of something equals 9. I don't even care what the something is at the moment. what could be inside here that would make this a true statement? The absolute value of what would equal 9? Negative 9. Yep. Or? Positive 9. So there's two possible solutions that we could end up with inside of there. So notice, and that means that this x plus 5 must be equal to either of those. The x plus 5 is going to be equaling plus or minus 9. Because if it equals a positive 9, after I take the absolute value, it's still going to equal 9. If it equals a negative 9, after I take the absolute value, it will still equal 9. But this looks awkward at the moment, because I have x plus 5 equals plus or minus 9. How, in my next step, am I going to do plus or minus 9 minus 5? That's weird to look at, right? And so whenever you're going to have to do more operations on the plus or minus number over here, rather than just writing it as equals plus or minus 9, just write it as two separate equations. Write it as the x plus 5 equals 9 and the x plus 5 equals negative 9. Now, a little side note here. Notice, the x plus 5 that was inside of the absolute value, it stayed the same, right? So notice, x plus 5, x plus 5, x plus 5. On none of those did I change it to x minus 5. And yet, by the end of today, I will probably see somebody trying to do that, because one of the big errors that I see when solving these absolute values is that somebody, instead of that, they'll write x minus 5 equals 9. That's not right. That's not what we're talking about here. Because remember, I'm wanting to make the inside of the absolute value equal the negative 9. That's not the same thing as just saying if I subtract it, I'm going to get 9. So, yes, you do need to spell it out this way. Now, once we split it up into our two equations like this, we just solve each of the equations individually, which means subtracting 5 on both sides of both equations. We just solve them each separately. And so here we see that we get x equals 4 and x equals negative 14. Which also points out one other thing. One other error that I will sometimes see is I will see people who will do this type of problem and they will just do this work over here. And that's all they'll write down. They'll just do that work and they'll say, okay, I got x equals 4. Therefore, the other answer is negative 4. As you can see proven here, that is not going to always be the case. It is not always plus and minus the same number. So you actually have to do that other work. All right, so having done those, you now can handle something like this. It's got all sorts of different little moving parts in it. So go ahead and write down and then solve this equation, please. And of course, starting it off, remember the very first thing you want to do is get the absolute value by itself. So notice that you're starting by getting rid of the 2 and the negative 5. And once you've done that, we end up with 6 equals the absolute value of x minus 9. Notice the absolute value is by itself, so this is where we're going to end up getting rid of the absolute value and therefore inserting the positive and negative versions. But in this case, since we will have to do more operations on it, I'm going to write it as two separate equations. And again, notice that inside each of those equations, it is x minus 9 for both. The only part where we switch the sign is over here on the 6. The part that was inside the absolute value stays exactly the same. And so when we then solve it by adding the 9s to both sides on both equations, we end up getting that x equals 15 and 3. And we're done there. We have our two solutions. And you might also see this written as x equals 3, 15. That does mean the exact same thing, of course. Now remember how we got here, though. We started by solving quadratics, and we saw that we needed two solutions there when we took the square root. Then we moved over to solving these absolute values. And here, solving the absolute values, we eventually got complicated to where we had to actually split it up into these two separate equations like we did here. But we didn't do any of those with the quadratics. Well, something similar can happen there as well. So we're going to be solving this one out next. We're going to go back to our quadratics and take a look at how some of those same skills are going to come into this. And just like with the quadratics that we saw earlier and with our absolute value, we want to get that quadratic part by itself first. Well, you notice that's already happened. We already have the quadratic first. And the whole idea behind that is that that means that the squared is now the outermost part of my function. So the squared is now what I have to deal with. So I'm going to be taking the square root of both sides. Now, when I take the square root of both sides, it's going to be x plus 5 equals, right? What will x plus 5 equal? Okay, it can equal 3. What else can it equal? Because remember, I'm squaring it here. 3 squared is 9. What other number squared equals 9? Negative 3. So we include the plus or minus. But just like with the other one, because that's going to have to do some operation on it, I then write that as two separate equations. So I go 3 equals the x plus 5, and I do negative 3 equals x plus 5. And again, you'll notice that the stuff that is on the inside here, the x plus 5, that did not change. That stayed the x plus 5. And this is the only tricky part of this problem, is getting to this point. Because once you're here, solving it shouldn't be too bad. Because all we have to do here is subtract the 5 from both sides in both equations to get my answers. And again, you'll notice here, x equals negative 2 and negative 8. It's not always going to be the same number, just a plus and minus. So yes, we actually have to do the two separate equations and work them out. All right, so having done those, let's do one last one here. This one pulls in a few more of the pieces. Go ahead and solve this one through. And before I start solving it, I want to just take a moment and talk about how do we know what strategy to use for this. Because like earlier this week, we were taking a look at problems where we had to solve it by factoring. How would I know whether I should be factoring it or not? It all comes down to how many x's you see in the equation at the start. Because as you take a look at this, you'll notice that the x only appears once. If the x is only in the equation once, you can just go through the process of moving everything from one side to the other, because you can actually end up with it as x equals. The types where we actually do need to factor it is where like you end up with the x squared plus something in front of the x equals 0, or whatever it would equal. But notice here it has the x and the x, and so that's why I would have to factor this type, but not the type we started with here. Alright, so since I don't need it on this, I'm going to go ahead and start by just adding 4 to both sides. That gets me my squared by itself. Now that I have the squared part by itself, I can undo the squared by taking the square root of both sides. When I do so, I end up with both the positive and the negative versions of the same number there. Again, remember, whatever was inside of the square root, it stays exactly the same. Both of them are x minus 7. And then I finish solving it out from there by adding the 7 to both sides of both equations. So we get x equals 12 and 2.